Drilling into electrical outlets is an extremely dangerous activity and should never be attempted. A commercial depicting this action could encourage viewers to engage in unsafe practices. The commercial may imply that homeowners are responsible for installing equipment, which is often not the case, as providers usually send trained technicians for the task. The connection between drilling into an outlet and needing professional installation isn't clear. It would be more effective to state clearly that free professional installation is offered. The commercial could portray homeowners negatively as incompetent, which could alienate potential customers. The advertisement misses the opportunity to highlight the benefits of professional installation, like increased safety, reliability, and warranty coverage. A more effective commercial could, firstly, emphasize the convenience of free professional installation, stating that technicians will handle everything. Secondly, it could highlight the value of professional expertise, ensuring safe and seamless installation. Thirdly, it could offer incentives such as a free subscription for a limited time when signing up for professional installation. By avoiding dangerous scenarios and focusing on the benefits of professional installation, a more positive and informative commercial could be created. Electrical safety is paramount, and portraying unsafe practices in media can have negative consequences. The dangers of electricity should always be taken seriously. Improper handling of electrical systems can lead to severe injuries, fires, and even fatalities. That is why it is important to rely on qualified professionals for any electrical work. When dealing with electricity, there are several key principles to keep in mind. Firstly, always disconnect the power source before working on any electrical circuit or device. This can be achieved by switching off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, use appropriate tools and equipment that are specifically designed for electrical work. These tools are typically insulated to protect you from electric shock. Thirdly, never work on electrical systems in wet or damp conditions. Water is an excellent conductor of electricity, and working in wet environments significantly increases the risk of electric shock. Fourthly, always follow the National Electrical Code, NEC, and local electrical codes when installing or modifying electrical systems. These codes provide guidelines and standards for safe electrical practices. Fifthly, if you are not comfortable or knowledgeable about electrical work, always hire a qualified electrician. They have the training and experience to perform electrical work safely and correctly. There are various types of electrical hazards that you should be aware of. One common hazard is electric shock, which occurs when electric current passes through the body. Electric shock can cause muscle contractions, burns, and even cardiac arrest. Another hazard is arc flash, which is a sudden release of electrical energy that can cause severe burns and explosions. Arc flash can occur when there is a fault in an electrical system, such as a short circuit. Overloaded circuits can also cause electrical hazards. When a circuit is overloaded, it can overheat and cause a fire. It is important to avoid overloading circuits by plugging too many devices into a single outlet or circuit. Damaged or frayed electrical cords can also pose a hazard. These cords can expose live wires, which can cause electric shock or fire. It is important to replace damaged cords immediately. Grounding is an important safety measure that helps to protect against electric shock. Grounding provides a path for electric current to flow back to the source in the event of a fault. This helps to prevent the buildup of voltage on metal surfaces, which can cause electric shock. There are several types of grounding systems that are used in electrical installations. One common type is equipment grounding, which involves connecting the metal enclosures of electrical equipment to ground. Another type is system grounding, which involves grounding the neutral conductor of an electrical system. Ground fault circuit interrupters, GFCIs, are another important safety device that helps to protect against electric shock. GFCIs monitor the flow of current in a circuit and quickly shut off the power if a ground fault is detected. A ground fault occurs when electric current leaks to ground, which can happen if someone touches a live wire. GFCIs are typically installed in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. When working with electricity, it is important to use personal protective equipment, PPE, to protect yourself from electrical hazards. PPE can include insulated gloves, safety glasses, and arc-rated clothing. Insulated gloves protect your hands from electric shock, while safety glasses protect your eyes from arc flash. Arc-rated clothing protects your body from burns in the event of an arc flash. Electrical safety training is essential for anyone who works with electricity. Training programs can teach you about electrical hazards, safety procedures, and how to use PPE. It is important to participate in regular safety training to stay up to date on the latest safety practices. There are many resources available to help you learn more about electrical safety. The Electrical Safety Foundation International (SV) is a non-profit organization that provides educational materials and resources on electrical safety. The Occupational Safety and Health Administration (OSHA) also provides information on electrical safety regulations and standards. Remember, electrical safety is everyone's responsibility. By following safe practices and being aware of electrical hazards, you can help to prevent accidents and injuries. If you are unsure about any aspect of electrical safety, always consult with a qualified electrician. They can provide you with guidance and assistance to ensure that your electrical systems are safe. One key aspect of electrical safety is understanding the different types of electrical circuits and their components. A basic electrical circuit consists of a power source, a conductor, and a load. The power source provides the electrical energy, the conductor carries the electrical current, and the load consumes the electrical energy. There are two main types of electrical circuits: alternating current AC circuits and direct current DC circuits. AC circuits are used in most homes and businesses, while DC circuits are commonly used in electronic devices and battery-powered systems. In an AC circuit, the direction of the electric current reverses periodically. The number of times the current reverses per second is called the frequency, which is measured in Hertz, Hz. In the United States, the standard frequency for AC power is 60 Hz. In a DC circuit, the electric current flows in one direction only. The voltage in a DC circuit is typically constant, while the voltage in an AC circuit varies sinusoidally. Electrical circuits can be connected in series or parallel. In a series circuit, the components are connected end-to-end, so the same current flows through each component. In a parallel circuit, the components are connected side by side, so the voltage across each component is the same. The total resistance in a series circuit is the sum of the individual resistances, while the total resistance in a parallel circuit is less than the smallest individual resistance. Electrical circuits are protected by circuit breakers and fuses. Circuit breakers are devices that automatically interrupt the flow of current in the circuit if the current exceeds a certain level. Fuses are similar to circuit breakers, but they are designed to melt and break the circuit if the current exceeds a certain level. Circuit breakers and fuses are rated in amps, which indicates the amount of current they can safely carry. It is important to use circuit breakers and fuses that are properly rated for the circuit they are protecting. Using an undersized circuit breaker or fuse can cause it to trip or blow frequently, while using an oversized circuit breaker or fuse can allow excessive current to flow through the circuit, which can cause a fire. Wiring is another important aspect of electrical safety. Wires are used to carry electrical current from the power source to the load. Wires are made of conductive materials such as copper or aluminum and are insulated to prevent electric shock. Wires are sized according to the amount of current they are expected to carry. The larger the current, the larger the wire size required. The National Electrical Code (NEC) provides guidelines for wire sizing based on the ampacity of the wire. Ampacity is the maximum amount of current that a wire can safely carry without overheating. Wires are also color-coded to indicate their function. Black wires are typically used for hot wires, which carry current from the power source. White wires are typically used for neutral wires, which carry current back to the power source. Green wires are typically used for grounding wires, which provide a path for electric current to flow back to the source in the event of a fault. When wiring electrical circuits, it is important to follow the NEC and local electrical codes. These codes provide guidelines for safe wiring practices such as proper wire connections, grounding, and overcurrent protection. It is also important to use the correct type of wire connectors and fittings. Wire connectors are used to join wires together, while fittings are used to connect wires to electrical boxes and equipment. Using the wrong type of wire connectors or fittings can result in loose connections, which can cause overheating and fire. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes are typically made of metal or plastic and are available in various sizes and shapes. Electrical boxes are required at all wiring junctions and terminations. It is important to use the correct type of electrical box for the application. For example, metal electrical boxes are required in areas where there is a risk of physical damage, while plastic electrical boxes are suitable for dry locations. When installing electrical boxes, it is important to ensure that they are properly grounded. Grounding electrical boxes helps to prevent electric shock in the event of a fault. Electrical panels are used to distribute electrical power throughout a building. Electrical panels contain circuit breakers or fuses that protect the individual circuits in the building. Electrical panels are typically located in a central location, such as a basement or utility room. When working on electrical panels, it is important to follow all safety precautions. Always disconnect the power to the panel before working on it. Use insulated tools and wear personal protective equipment, such as safety glasses and insulated gloves. Never work on electrical panels in wet or damp conditions. Lighting is another important aspect of electrical safety. Proper lighting can help to prevent accidents and injuries by improving visibility. There are various types of lighting fixtures available, including incandescent, fluorescent, and LED. Incandescent lighting is the oldest type of electric lighting. Incandescent bulbs produce light by heating a filament until it glows. Incandescent bulbs are inefficient and have a short lifespan compared to other types of lighting. Fluorescent lighting is more efficient than incandescent lighting. Fluorescent bulbs produce light by passing an electric current through a gas-filled tube. Fluorescent bulbs last longer than incandescent bulbs and produce more light per watt. LED lighting is the most efficient type of electric lighting. LED bulbs produce light by passing an electric current through a semiconductor material. LED bulbs last much longer than incandescent and fluorescent bulbs and produce even more light per watt. When installing lighting fixtures, it is important to follow the NEC and local electrical codes. These codes provide guidelines for safe lighting practices such as proper wiring, grounding, and fixture support. It is also important to use the correct type of lighting fixture for the application. For example, recessed lighting fixture should be used in ceilings, while track lighting fixtures can be used to highlight artwork or other features. Appliances are another important aspect of electrical safety. Appliances consume electrical power to perform various tasks such as cooking, cleaning, and entertainment. Appliances can be a source of electrical hazards if they are not used properly. It is important to read and follow the manufacturer's instructions for all appliances. Do not overload circuits by plugging too many appliances into a single outlet or circuit. Use extension cords sparingly and never run them under rugs or furniture. Inspect appliances regularly for damage and repair or replace them if necessary. When using appliances in wet or damp conditions, such as bathrooms and kitchens, it is important to use ground fault circuit interrupters, GFCIs, to protect against electric shock. GFCIs are required by the NEC in these areas. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage electronic equipment. Surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protectors are devices that protect electronic equipment from surges by diverting the excess voltage to ground. Surge protectors should be installed on all electronic equipment, such as computers, televisions, and stereos. There are two main types of surge protectors: plug-in surge protectors and whole-house surge protectors. Plug-in surge protectors are installed at individual outlets, while whole-house surge protectors are installed at the electrical panel. Whole house surge protectors provide better protection than plug-in surge protectors because they protect all of the circuits in the building. Electrical inspections are an important part of maintaining electrical safety. Electrical inspections are performed by qualified electricians to identify potential electrical hazards. Electrical inspections can help to prevent accidents and injuries by identifying and correcting electrical problems before they cause harm. Electrical inspections are typically required when buying or selling a home or when making significant electrical renovations. It is also a good idea to have your electrical system inspected periodically, even if it is not required. The NEC is a comprehensive set of standards for safe electrical installations. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is used by electricians, electrical inspectors, and other professionals to ensure that electrical installations are safe and compliant with industry standards. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC is a complex document, but it is essential for anyone who works with electricity. Electrical safety is the shared responsibility. By following safe practices and being aware of electrical hazards, everyone can help to prevent accidents and injuries. If you have any questions about electrical safety, consult with a qualified electrician. They can provide you with guidance and assistance to ensure that your electrical systems are safe. Remember, electricity is a powerful force that can be dangerous if it is not handled properly. Always take precautions and follow safe practices when working with electricity.